it, and go ahead, Luke.
Hello, good morning or midday, everyone, depending on your time zone. My name is Luke Newport. I'm a technical specialist at Microsoft in the data and AI space. What that means is that I help folks kind of understand and onboard into the Azure and data space for us. Previously at Microsoft, I spent the bulk of my career as a support engineer in the SQL Server product. So today we're going to talk about Azure Data Factory data flows, and we're going to start off with a little bit of a refresher on what Azure Data Factory is. So if you haven't heard of Data Factory, this is our cloud-based data integration service. If you think about data integration all up at Microsoft, we have had SSIS around for a long time in the product, that's SQL Server Integration Services. So that's been, primarily an ETL type engine to and from SQL Server. You can scale up. It has a great ecosystem around BIML, like business intelligence, modeling language, task libraries, and so on. Very good for kind of your on-prem and some cloud-based ETL, and I use ETL specifically, extract, transform, and load, because typically SSIS hasn't been used as a straight extract and load. There's some kind of transformation that's taken place. We also have, we can run that in Windows or Linux, and also in Azure and Azure Data Factory. So Data Factory, the product has been around for a while in Azure. We're currently on iteration 2 V2, which brought with it, an application model that's very similar to SSIS in that there is a control flow, which controls the orchestration of data, and the data flow, which is actually movement of data. It's completely serverless, so we have a great, portal for monitoring and data movement and so on. With 70 plus connectors, I think there's actually probably more now. These are being added, month over month or release over release. So those connectors are anything from Azure to Amazon, Google, Oracle, SAP, and so on. It has a great visual programmatic authoring and monitoring space, as well as a good data transformation, data flow space, which we're going to talk about today. The other thing that ADF can do is it can host your existing SSIS packages. So you can take your SSIS packages you have on-prem today, change your connection strings typically, and have them just work up in Azure, inside of Azure Data Factory, with no VM management within that. So, like I said, Data Factory, we have, kind of a new pipeline model, which is different. We'll talk about what a pipeline is. We have what we kind of term as data movement as a service. So it's cloud and hybrid with 70 plus connectors. And then today we have the data flows, which we're going to talk about. This uses visual authoring, code free. It's a very analogous to what SSIS could do in the transformation space, but it uses Databricks behind the curtain for computes. So again, we have SSIS and authoring and monitoring and so on built within that. So let's review a little bit about Data Factory entities and how they all relate to one another. So first up is the concept called a link service. So link service is, this can be SQL Server, Hadoop, or Databricks. This is essentially the service running or providing a data set. So that's number two. So this data set represents data items stored inside of a link service. I think someone's off mute there. Someone might want to. You can mute yourself. Hearing a little bit of background noise. So the data set consumes a link service, or is consumed by an activity, I should say. So an activity is something from like spinning up a Hive job, a stored procedure in SQL, a copy job, and then an activity can also produce a data set back into a link service after you have done some kind of work on it. And then what contains all of these together is something called a pipeline, and the pipeline is the unit of scheduling that we have from an Azure Data Factory perspective, where the contains a grouping of activities that run jobs and so on across data sets and link services. So prior to the data flows, what does Azure Data Factory service do today? And this is kind of a common use case, one of our kind of core use cases, we could say. So let me just kind of walk through where ADF fits in. You'll see this ADF logo here. This little tower with the triangles off the side. So in this case, we have a call center. The call center takes calls, and it has some kind of customer table and a relational data store, which has information about the customer. So we need to somehow determine, or see if we can determine through a machine learning model which customers are likely to churn, right, in this example. So from a data factory perspective, we can both ingest call log files and on-premises data mart into an Azure Data Lake, for example. And then this is in the ingest phase. So the data factory would orchestrate that piece. And then further on down in this pipeline, it would call external services, so Hadoop or ML or whatever, to run your ML model, run your custom code, whatever it is, across these datas that have been merged into Hadoop in this case, through some kind of analysis. And then based off of your ML model, you've determined which customers are likely to churn. And then further on, we still have Data Factory involved here on the right-hand side that takes those that churn prediction model and then populates data warehouse in this case, but it could be anything, for customer churn tables so that you can then visualize it in Power BI. So this is kind of all up how we envision and how we use Data Factory. This is one of many types of examples that can be done here. But if you're familiar with the concepts of data orchestration integration, if you're looking at this, this is what we would call an ELT type model, where during the ingestion phase, we're not really doing anything to transform the data, to cleanse it or do anything else. We're doing something called an extract, a load, and then transform. This is common in a modern data warehouse and data lake, and there's great reasons to do it. But one of the things that has been missing from Data Factory up until the introduction of data flows is the ability to actually transform data, cleanse data, and do data engineering on the way in. So you would always have to call some kind of external service to do that, whether that's Databricks or whatever, or Hadoop. So that brings along the concept of data flow activities. So it is an activity, and you saw that the activity is one of those things we can host within a pipeline, and it allows you to do essentially, cloud first, scale out, ELT or ETL. So I realize those things kind of get used interchangeably in elevator type conversations, but they are different. But this allows you to have essentially code free, apart from a fairly easy to use and learn expression language, from a visual standpoint, to go through and write these pipelines out. Completely serverless from your perspective. It does use Databricks on the back end. Doesn't require any kind of Spark or Scala or Python or Java requirements. It's going to be very familiar to anyone who's used something like Informatica or SSIS, and very resilient from large unstructured data requirements. You can pull in unstructured data, structured data, use things like schema drift handling and other things. And within this can all be operationalized and scheduled from within the pipeline standpoint. So some of the key tenets we have from a visual data flow, we have, it's completely visual from the authoring standpoint. It can be embedded. The UI can be embedded inside of your ISV or software as a service app. We have a graphical UI, which I'm going to do a demo for you here, and built-in resiliency. This is kind of a preview of what it might look like, but I'll link to a blog that one of my fellows wrote about how to compare a Databricks job to a Data Factory data flow, but very different. Certainly, if you're comfortable in Python or Scala, nothing wrong with that. But this is more for your traditional, data integration type folks to do things like cleansing and aggregation and conversion, and data exploration is another big piece of this as well, without having to write code there on the right. So data flow workstream. This works kind of like a Data Factory workstream. So you have your data sources. This is where you define a data source. So whether it's a table or whatever it is, or blob store, CSV, Parquet, and then you have staging. You can define a staging account from within your source. By default, you use a data lake staging area. You don't need to do anything with it, but you can manually configure a staging area if you like. And we support all kinds of file formats. So So within that, you have another explicit user action, which I'll kind of show you. We have sorting, merging, joining, pivot, unpivot, window functions, unions, derived columns, all the type of things you might be used for within these transformation steps. And then you would do something in a destination, or what we call syncing the data. So that's, again, an explicit user choice where you go through and connect all that data you've gone through and cleansed and land it somewhere. Let's kind of take a look at this in action. So first off, a couple different things here. Let me actually close this data set. So this is the Data Factory portal. If you're not familiar with it, This is what you would get when you go into the front page. We have, I think, some good tutorials here. These three icons over here on the left, and I know this is kind of a small screen, have kind of the key parts that we have. So we have the overview, and then we have this pencil here, which is our authoring surface, and then we have this speedometer here, which is our monitoring surface. So let's jump over to the authoring real quick. I did it by clicking on the pencils. And we have three pieces here. This has kind of been in flux a little bit, and we've added some improvements here, such as folders and so on. First off, I don't have this configured to use a repository, but it can use VSTS or GitHub as your repository. We have the concept here that I talked about earlier, pipelines. So the pipelines, if you remember, is the collection of activities. So I'm clicking on this incremental copy pipeline here, and we have this grouping of activities. This one happens to be a Delta load for a copy from SQL to on-prem, or SQL on-prem to Azure, right? And then we also have pipelines that contain data flows. So for example, I'm going to show you some of these data flows, but this data flow, again, this pipeline, this currency converter, and this movie demo pipeline have one data flow each inside of them. Within the data flows themselves, so we're going to go down here in the data set. I'll show this here when I get to the data flows. Let's walk through some of these, kind of what you do from an end-to-end standpoint. So here we have an idea of a currency converter. And so from left to right, this is how you would read it. So we have, a couple different types of currency files coming in, one from a US and one from Canadian. Each one of those defined over a data source. You can see down here, if we take a look at this data source, let's actually connect over, you'll see that this is in a Azure Blob link service. We can actually preview the data here real quickly, just kind of give you an idea where we got. And you can see we have 4 columns. They're not necessarily named, so we have some properties. So what we want to do is we want to take this US currency source and this Canadian source and do something called a union on top of it. So we're going to actually, from within this, you can do all kinds of things here, but in this case, we actually did a union. So we have a union operator, which goes through and unions by name on the Canadian source. And it goes through and creates a new currency column by essentially taking the currency rate and doing an expression, a rounding expression on top of it. And we're going to look at expressions in the next data flow more in detail, but it'll go through and do that conversion on the current conversion rate column. It's going to average things out. And then we do something called a conditional split. Here we have, on this case, we have a conditional split, and it's going to route on a data type. So it's going to look in this currency column, and whether it's in US data or Canadian data, it's going to land it into 2 different sinks. So from end to end, this is kind of left to right what it looks like. If I go through and look at the actual execution of this, you can see that I clicked on my monitoring here, and I clicked on the run that I ran last night, and I click on my eyeglasses here, and you can see kind of an execution plan. And you can kind of see what went on through that. I'm going to show you here when we get to the taxi demo, some data lineage stuff around this. So next one, let me kind of show you another piece here, which is pretty interesting. So this is the data engineering piece, and I went ahead and connected this up to my cluster and started it because it takes a minute or two, but this is an interesting use case apart from just doing ELT. This allows you to do some data exploration, which if you've sat in on any Databricks, talks or you've learned anything about that, that's kind of one of the key tenets is the ability, when you're first doing data science or data exploration, kind of understanding your data. So I created a new data flow here called Dataflow 1. Added a new source, maybe it's DB dataset, which is just my a connection to a CSV file. I'm going to preview that data for you here real quick. This is sitting out in Azure Blob Storage. And you can see I've got, movies, titles, a misspelled column, years, bad here, negative 1980. So kind of a cool thing you can do with that is, let me go back to my Dataflow 1 here, is go through and do some engineering on top of it. One of the interesting things I did here is I started to do a debug session. So what that means is that I'm going to connect over to my Databricks cluster. You can see that my cluster is already running. If you don't have it running, it'll spin it up for you. My Databricks cluster is configured here in my cluster workspace. I have one sitting here running. It has a couple of nodes. You can have an auto scale or not. But in this case, when I'm selecting my source, I know that I have good consistent CSVs coming in, so I don't have to allow schema drift. Although we will allow schema drift, and I'm going to give you some videos on how to enable that. But to sort of allow for columns showing up at different places or columns not showing up, depending on your input. And then we go through and define the schema. So I went ahead and imported from the data set. I have a few strings here and a few integers. Optimization tab, this will allow you to do some different advanced partitioning, Spark partitioning, depending on how you have your Databricks cluster set up. But the important piece is this data preview. So let me go through and see if I can, data preview again. What's cool about this is that I actually ran this on my cluster already. It takes a couple seconds, but you can go through and do cool things like statistics over your data. So if you have, if you size your Databricks cluster appropriately and you have very, very large amounts of data, you should be able to pull interesting statistics back about the type of data you have in each one of these. Remember, this is just a CSV, but this could be, many terabytes large, and it could be just as quick just by scaling your Databricks cluster up and down. And by the way, this Databricks use is only, we're only going to be paying for the use while we actually run this. That's kind of a cool elastic standpoint here, that as you're going through and exploring your data, that Databricks cluster will shut down after X minutes of inactivity, depending on how you configure it. But cool things in this, from a year standpoint, I know that I define this as an integer. So it goes through and builds a nice histogram for me where I can see my distribution of data and other cool information, around the type of data that we have. So we saw from the data beginning that we had some issues with the movie title. So what if I want to go through and clean that up a little bit? I can go through and create a derived column on top of that. We're going to use our expression language to actually do that. So we're going to do it on the title column. And actually, we're going to call it clean title. And we can go through and actually run some expressions on top of this and look and see what it looks like, for example. So we knew that we want to find, well, I'm going to pull all the parentheses out in this case. So I'm going to locate the offset where I actually have a paren, a space, and then an open paren inside of my title column. So I'm going to save that, click refresh, and this submits the job down to Databricks. So I'm going to get 2 columns on the output here. This takes a second. So you can see that I have, yep, sure enough, I have, 14 characters in. I'm going to be able to determine, so just to trim off on the left-hand side. So furthermore, on my expression, I can just go, all right, so left of that, locate, I want to trim everything off of that. So I'm going to save that, run it again. You can see we have tons of expressions kind of built in, and these are well documented. All this stuff is currently hosted out in GitHub. We're going to be publishing the docs out here pretty soon. But here's another problem. From an expression standpoint, it's only pulling things out if it finds this conditional, left expression. So the locate, but we can do things like an if condition. So essentially, if my locate is 0, then just give me the title. If I do find it, otherwise, give me that entire left, right? So this should be able to give us, the title, regardless of whether or not we find that open paren on the left-hand side. This is kind of just, an example of the type of data engineering and debugging you can do. So if you have someone kind of trying to figure out their expression language, they're hooked up to Databricks, and they could be running this across a very large data set. One thing I should point out, I'm going to go ahead and save and finish this, is that when I selected my debug up here, I had my cluster already started. If it wasn't started, it would start it up. It takes about 5 to 7 minutes. Inside of my source settings, I am limiting how many rows I'm pulling off the top of that. So if you just kind of wanted to sample, some smaller amount, that's a good thing to keep in mind. So then further on down the pipe, you've got your drive column. You can choose to kind of sync that, whether that goes in wherever. All right. So moving on down to the taxi demo, this is kind of another, and by the way, when you sign up for the preview, in fact, you don't even have to sign up anymore. If you just instantiate a data factory in East US or Southeast Asia, you can choose the option to have data flows enabled, and you'll get these 3 demos on there: currency converter, movie demo, and taxi demo. And the document links I have at the end of the slides will show you how to do that. You can just also do a search for GitHub ADF data flows. But from within this taxi demo here, we have a lot of other things we can do. For example, we have joining again across a union, and then doing aggregations. For example, if I want to, in this case, I want to find the day of the week, for example, based off of a pickup date time, right? So give me the day of a week, Monday, Tuesday, Wednesday, based off of the time, another type of expression we have built in. Aggregate here, a different type of aggregation, for example, that actually looks and sees, it will aggregate across my payment type. I actually have, 4 different payment types you can see, and if I can find them in the demo for you here. Whether it's cash or, yeah, I don't have this hooked up to the cluster, so it'll take a few minutes. But if we have cash or credit or whatever it is, we would aggregate by that type of payment type. How much we have for each type of each. Final piece I wanted to show you around this before we get finished here is the execution plan. So what's kind of cool from this perspective is that if you go down in the monitoring space, and I ran a few of these last night, if I look in my taxi demo pipeline here, I clicked on my monitoring speedometer, then I clicked on my little pipeline here, and I'm going to click on my glasses. So pretty easy to understand if you're running 1 or 2 of these, but what if you're running thousands or hundreds a day? This is what we would call kind of an execution plan. If you're familiar with SQL Server, you kind of get the idea. But what happens within each one of these, you not only have good information about the number of rows that you pulled over, how long each transformation step took, whether you're doing, trip fare calculations or aggregations like I showed before. But another cool thing is the fact that if you look at these sinks here at the end, so this is where you're actually landing the data, we're actually showing some pretty interesting things around where the original source data came from. So for example, we have, 3 different types of methods here. So passenger count, for example, right? we're syncing this data in, but where did this came from? This came from, a calculated value from trip data, right? So for my original source there, trip data. Another type is this type of mapping. So we didn't do any kind of, transformations or calculations across vendor ID that just went straight through from trip data all the way down to our vendor data sync in this case. And then another type of method for the data lineage is this method of used, where we're not syncing this data. So you know that by the fact that we don't have any kind of column specified here on the left, but we use these columns in some sort of aggregation in each case or whatever it was to figure out some other trip fare or trip distance and so on. So pretty cool from a transformation perspective. Let me pull up my slide deck here. Last thing, go ahead, David.
Look, I think there are some questions in the item window.
Go for it. Let's see if I can find them here. Is it in public preview? It is. I want to say maybe. It's really easy to get on the preview. If not, I believe you can actually go through now and create a data factory in either East US or Southeast Asia. If not, you can go to this GitHub document here, which actually, I don't know if you're going to get the deck, so let me just copy this link and see if I can drop it down in there. Yep. Oops, I put too many in. Go there to this GitHub, and it has all of the documents and videos. Mark Cromer, who PMs this thing, he has great YouTube videos. He has about 20 of them up right now, like with each one of the expressions that we have, pivot, unpivot, window, and so on. Those are all there to kind of play with. But yeah, so we have great data factory documentation. I'm really proud of these docs. I think docs overall have been greatly improved, especially in the Azure space. All these ADF data factory data flow documentations are being developed right now in GitHub. You can watch those. You can use that right now to kind of build out your data flows. If you want to get started before that, then certainly go through our 10-part lab series that we have here linked in the resources for learning about Azure Data Factory proper. All right, I'm trying to import a CSV into Azure SQL table. As part of the process, need to remove the first 2 lines through skip line features, but ADF doesn't recognize the scheme of the CSV after remove the first 2 lines. I think you can do an offset. Srini, drop me an email, L Newport. You can do the first. You can do the first line and then do an offset into the data. You should be able to do the column headers and then do an offset into the data if you have a known value like that. So that's what I had for you today. Any other questions? How does Dataflow handle joins with large data set on the right side of their partition parquet? What do you mean, just in terms of performance?
Yeah, performance and partition elimination.
Oh, partition elimination. So that's a good question. I may have to drop me a line on that. I think that it would handle it. I mean, so essentially, it's going to be analogous to how Databricks does it. So we're actually compiling this down to Scala on the other end. So if we do partition elimination in Databricks, and we're using Parquet for sure. I haven't done that specific example in Dataflows, so I would have to look at it.
All right, thanks.
Yep.
Any other question, folks? I mean, if you want to ask, please, unmute and ask. We have 2 more minutes, so.
Yeah.
Yeah, this is Srini here. When can we expect this in Azure government regions?
Ooh, great question. I honestly don't know. I'll ask again. Drop me a line, and I'll ask the PM and reach out and get back to you if we have an answer around that.
Thank you.
Yep. And by the way, that's my email there, L Newport. Can you put the 10-part series link here in Teams? Yes, I will do that right now.
Just checked, and the V2 with the data flow preview is available on.
Yeah, I thought it was.
So, question: when this GAs will V2 data flows that have been provisioned without this feature automatically have it available, or there would be a migration that's needed?
I don't know. I don't think it would be a migration because it's just another activity. If you've been paying attention to Data Factory development, my Data Factory, for example, and my customers' Data Factories have been kind of just being updated with things like different UI improvements and other stuff kind of in line. Since this isn't a big rewrite, it's just an additional activity. I don't believe so, but I'll verify.
Thanks.
So I think we are right on time.
Yeah.
Thanks, Luke.
Yeah.
Very informative.
Thanks for joining me.
Learned a lot. So thank you. And by the way, folks, the video will be uploaded to YouTube, and in the description will be the link to the presentation. And Luke, you're going to send me the presentation.
Yes.
Is that right?
Yep. So all the links will be there, and I have other
Great.
appendix type things here at the end, so more stuff for folks to look at.
Perfect. Thank you, and hope everybody had a great weekend.
All right. Thanks.